Hey everyone, and welcome back to Mind and Matter, the channel where we explore the vast universe inside our heads and the infinite cosmos surrounding us. Today we're diving into the top 10 mind-blowing science experiments that have revolutionized our understanding of the universe and ourselves. So buckle up, get ready to have your mind blown wide open, because we're about to explore some of the most incredible, thought-provoking, and even controversial experiments in human history. Let's kick things off with a real head-scratcher, the double-slit experiment. Picture this. You've got a beam of electrons, those tiny particles that make up everything around us. You fire them at a screen, but there's a catch. You put a barrier in front of that screen with two slits in it. Common sense tells us the electrons should pass through the slits and create two distinct bands on the screen, right? Wrong. Instead, they create an interference pattern, like waves crashing into each other. The crazy part is, they do this even when you fire the electrons one at a time. It's as if each electron is going through both slits simultaneously. If you try to observe which slit the electron goes through, say by shining a light on it, the interference pattern disappears. The act of observation forces the electron to choose a path, collapsing the wave function and making it behave like a particle. So what does this mean? Well, it suggests that consciousness, the act of observing, has a direct impact on reality. The double-slit experiment throws everything we thought we knew about the nature of reality out the window. It challenges our very understanding of cause and effect, suggesting that the universe is far stranger and more interconnected than we could have ever imagined. From the subatomic world to the complexities of human behavior, our next experiment takes us deep into the heart of social psychology, the Stanford Prison Experiment. What happens when you take a group of ordinary people, put them in a simulated prison environment, and assign them roles as guards and prisoners? That's the question that psychologist Philip Zimbardo set out to answer in 1971. Within days, the guards, ordinary college students, began exhibiting authoritarian and abusive behavior toward the prisoners. The prisoners, also college students, became passive, withdrawn, and deeply distressed. The experiment, originally planned for 2 weeks, had to be shut down after just 6 days due to the severity of the psychological harm inflicted on the participants. It serves as a stark reminder of the dangers of unchecked authority and the importance of individual responsibility. Now let's shift gears to an experiment that's less about mind-blowing revelations and more about the sheer audacity of scientific curiosity: the pitch drop experiment. Imagine a substance so thick and viscous that it appears solid to the naked eye. That's pitch, a derivative of tar. But is it truly solid? Or is it, in fact, a liquid that flows incredibly slowly? To find out, Professor Thomas Parnell set up an experiment at the University of Queensland in Australia in 1927. He heated some pitch, poured it into a sealed funnel and waited, and waited, and waited. It took 8 long years for the first drop of pitch to fall. Since then, 9 drops have fallen, each one a testament to the relentless march of time. The pitch drop experiment is a reminder that some of the most profound discoveries come not from sudden breakthroughs, but from the patient observation of the universe as it unfolds over decades, even centuries. So, the next time you're feeling impatient, just remember the pitch drop experiment. Some things are worth waiting for. Let's dive into another experiment that delves into the complexities of human behavior, one that's as unsettling as it is revealing: the Milgram Experiment. Conducted in 1961 by psychologist Stanley Milgram, this experiment sought to understand the limits of obedience to authority, even when it conflicted with personal conscience. Imagine yourself as a participant in this experiment. You're told you're involved in a study about learning and memory. You're assigned the role of the teacher, while another participant, actually an actor, is the learner. Your task is to administer electric shocks to the learner every time they get an answer wrong, increasing the voltage with each mistake. As the experiment progresses, the learner's cries of pain become more and more intense. You want to stop, but the experimenter, an authority figure in a lab coat, insists that you continue. Shockingly, 65% of participants went all the way, administering the highest level of shock, 450 volts, despite believing they were causing serious harm to another human being. The Milgram experiment showed us the terrifying power of authority figures and the ease with which we can abdicate our own moral responsibility when following orders. It remains a stark reminder of the dangers of blind obedience and the importance of critical thinking and moral courage. Sometimes the most mind-blowing science experiments are the ones you can do right at home with everyday objects. Take, for example, the candle in a jar experiment. Here's how it works. You take a candle, place it in a shallow dish of water, and light it. Then, you carefully lower a clear glass jar over the candle, sealing it within. As the candle burns, it consumes the oxygen inside the jar. Eventually, the flame flickers and dies out. But that's not the end of the story. The water level inside the jar begins to rise, seemingly defying gravity. When the candle burns, it doesn't just consume oxygen. It also produces carbon dioxide and water vapor. The water vapor condenses on the inside of the jar, but the real key is the consumption of oxygen. Air is composed of different gases, mainly nitrogen and oxygen. When the oxygen is used up by the flame, it creates a partial vacuum inside the jar. The air pressure outside the jar remains higher, and this pressure difference forces the water up into the jar, replacing the volume occupied by the consumed oxygen. The candle in a jar experiment is a fantastic example of how even the simplest demonstrations can reveal profound scientific principles. It's a reminder that science is all around us, waiting to be discovered and understood, even in the most ordinary of places. Now let's venture into the realm of thought experiments with one that has puzzled and intrigued physicists and philosophers for nearly a century: Schrödinger's cat. This thought experiment, proposed by Erwin Schrödinger in 1935, highlights the bizarre and counterintuitive nature of quantum mechanics. Imagine a cat sealed inside a box along with a diabolical contraption. This contraption consists of a radioactive atom, a Geiger counter, a device that detects radiation, a hammer, and a flask of poison. The radioactive atom has a 50% chance of decaying within an hour. If the atom decays, the Geiger counter detects the radiation, triggering the hammer to smash the flask, releasing the poison, and killing the cat. If the atom doesn't decay, the cat lives. According to the principle of quantum superposition, until we open the box and observe the cat, it exists in a superposition of states, both alive and dead simultaneously. It's only when we make an observation that the wave function collapses, and the cat chooses one state or the other. Schrödinger's cat isn't meant to be a literal experiment. It's a thought experiment designed to illustrate the strangeness of quantum superposition and the challenges of applying quantum principles to the macroscopic world. It highlights the fundamental difference between the quantum world, where particles can exist in multiple states at once, and the classical world we experience every day, where objects have definite properties. From the quantum realm, let's shift our focus to the world of human psychology, and an experiment that has profound implications for our understanding of self-control and success: the marshmallow test. This deceptively simple experiment, first conducted in the 1960s by psychologist Walter Mischel, has become a classic in the field of developmental psychology. Here's the setup. A child is placed in a room and presented with a tempting treat: a marshmallow. They're told that they can eat the marshmallow now, or if they can wait for a short period, say 15 minutes, they'll get 2 marshmallows. The catch? The researcher leaves the room, leaving the child alone with the marshmallow and their own willpower. The experiment is a test of delayed gratification, the ability to resist a smaller, immediate reward in exchange for a larger, delayed reward. What researchers found was fascinating. Children who were able to delay gratification, those who waited for the second marshmallow, tended to have better life outcomes later on. They scored higher on standardized tests, had better social skills, were more likely to attend college, and were less likely to engage in risky behaviors. The marshmallow test highlights the importance of self-control and the ability to regulate our impulses, skills that are essential for achieving long-term goals. Sometimes the most mind-boggling scientific discoveries are the ones that seem completely counterintuitive, defying our everyday experience. Case in point, the Mpemba effect. This phenomenon, named after Tanzanian student Erasto Mpemba who observed it in the 1960s, states that under certain conditions, hot water can freeze faster than cold water, even though it seems to defy logic. Imagine taking 2 identical containers, one filled with hot water and the other with cold water, and placing them in a freezer. You'd expect the cold water to freeze first, right? However, under certain conditions the hot water can actually freeze faster. The exact mechanisms behind the Mpemba effect are still debated, but several theories have been proposed. One theory suggests that evaporation plays a role, as hot water evaporates more quickly, reducing the overall volume that needs to be cooled. Another theory posits that convection currents within the hot water, caused by temperature differences, may facilitate faster cooling. The Mpemba effect is a fascinating reminder that even in seemingly simple phenomena, there's often more than meets the eye. It highlights the importance of questioning assumptions and embracing the unexpected in the pursuit of scientific understanding. Get ready to have your sense of self challenged with our next experiment, which delves into the fascinating world of neuroscience and the malleability of our perceptions, the rubber hand illusion. This experiment demonstrates how easily our brains can be tricked into accepting external objects as part of our own bodies. Here's how it works. You sit at a table with one hand hidden from view, perhaps behind a screen. A realistic-looking rubber hand is placed in front of you, aligned with your hidden hand. Then, the experimenter simultaneously strokes both your hidden hand and the rubber hand with a brush. As the stroking continues, something remarkable happens. You begin to feel the sensations of touch, not on your hidden hand but on the rubber hand. The illusion becomes so convincing that if the experimenter tries to hit the rubber hand with a hammer, you might flinch or even feel a sense of pain, even though your real hand is safely out of reach. The rubber hand illusion reveals the remarkable plasticity of our brains and the way our senses work together to create a coherent sense of self. It suggests that our brains constantly update our body image based on sensory input, and when presented with conflicting information, they can be tricked into incorporating external objects into our sense of self. Let's wrap up our mind-blowing journey with an experiment of truly cosmic proportions: LIGO, the Laser Interferometer Gravitational Wave Observatory. This groundbreaking project, which made history in 2015, marked the culmination of decades of research and engineering, aimed at detecting one of the most elusive phenomena predicted by Einstein's theory of general relativity: gravitational waves. Imagine two black holes, those cosmic monsters with gravitational pulls so strong that not even light can escape, locked in a deadly dance billions of light years away. As they spiral toward each other at unimaginable speeds, they warp and distort the very fabric of space-time, sending out ripples, gravitational waves, that propagate outward at the speed of light. These ripples are incredibly faint, stretching and squeezing space-time by less than the width of an atom, making their detection a monumental challenge. This is where LIGO comes in. Using two incredibly precise interferometers located thousands of kilometers apart, LIGO can detect these minute distortions in space-time caused by passing gravitational waves. In 2015, LIGO made history by detecting the first-ever gravitational waves, confirming Einstein's predictions and opening a new window into the universe. The discovery of gravitational waves marked a new era in astronomy, allowing us to study some of the most energetic and cataclysmic events in the universe, such as black hole mergers and neutron-star collisions. So there you have it, 10 mind-blowing science experiments that have challenged our assumptions, expanded our understanding, and left us with more questions than answers. From the subatomic world to the vastness of space, science continues to reveal the secrets of the universe, pushing the boundaries of what we thought was possible. Science isn't just in labs or textbooks, it's everywhere, revealing the unseen, explaining the impossible, and challenging what we think we know. It's about curiosity, exploration, and the never-ending quest to understand the world around us and our place in it. Which experiment blew your mind the most? Let us know in the comments below. And don't forget to like, subscribe, and tap the bell, because here at Mind and Matter, we turn curiosity into understanding. Until next time, stay curious.